Hello again, everyone. So I'm here again to discuss to you another topic for engineering. So now we have annuity. Okay, so for annuity, we have four types of annuity, and we will discuss the first one and the easiest one. And this is the foundation of annuity. Okay. So for ordinary annuity, so as you can see, we have four types. We have ordinary, due, deferred, and perpetual. So the first one is the ordinary annuity, and the payments are made every end of the month. Okay, so if you watch my previous videos, you already know that for compound interest, we have only one payment, a lump sum in a year, where we will reflect that money into another year. So for example, so let's say we have here a cash flow diagram, and we have here, let's say, two payments or two obligations. Okay, so let's say we have here a payment, and let's say we have another one, and then let's say this is our year zero, and let's say this is our year 8. Okay, so if I have here a lump sum of money, let's say 10,000, and then we want to reflect this one to here, to the 8 years. So all we have to do is that 10,000 times 1 plus I raised to yn, right? Now, for annuity is a little bit different. Okay, so let me just erase this. Okay, so making a new cash flow diagram. Let's say we have a payment here, here. Okay, so for annuity, so for the compound interest, you are paying only one time, right? One time, and then you can reflect it whenever, wherever year you want. But for annuity, what we will have here is you have to pay every month, or depending on the method of compounding. So if the method of compounding is quarterly, you have to pay quarterly, every quarter. If the method of compounding used is monthly, you have to pay every month. Okay? So what we will have here is, let's say this is our year 0, 1, 2, 3, and okay. And then let's make it a 1, let's make it 1, 2, 3, 4, and 5. There you go. And 5. And let's say that I am paying, let's say I'm paying 10,000 every year. So what we will happen here, this is what it's gonna look like. So you will have a payment here, all of this one. Let's say payments here. So you'll have payments here, and that means that I am paying 10,000 for the whole 5 years. Okay, for the whole 5 years. And now, that is what the cash flow diagram looks like if that is an annuity. Okay, so you see the difference that you have here a straight line, that simply means that the individual or the person is paying for the whole 5 years. Okay, so you can reflect it. Let's say this is our 6th and 7th year. You can reflect a lump sum of 10,000 here. Okay, you can also do that, or you can also reflect it at 6 years. Okay. Now, reflecting or showing you the formulas for that, we have two formulas, right? So, for you to know the future worth, we have here A, that's the amount of annuity, times 1, that's the bracket, that is 1 plus I raised to y, n minus 1 all over I. Okay? So that's your formula for future. If you're going right? If you're going right or going to the future, that would be your formula. Or we can also rewrite this as a times, we all know that I is just equal, it's also equal to 1, j over n, right? 1, oops, 1 plus j over n raised to yn minus 1 all over. We all know that I again is, we can replace this I with j over n. Okay. So for, if you're looking now for present, of course, as I told you from the last videos, uh, if you're going left, make sure or remember that exponents must be negative. So instead, we will have here 1 minus 1 plus I raised to negative, must be negative 1 all over. Of course, you can also rewrite it as a, so 1 minus 1 plus a j over n raised to negative yn all over j over n. There you go. So this will be our formulas or the formulas that we will use for the rest of this video. So with that, I think we can move on to our sample problems. Okay, let's have our first problem. So we have, in El Salvador just bought a car in an installment basis. So if he is to pay 15,000 per month for a 7% interest compounded monthly for 5 years, how much is the accumulated amount? So as you can see, this happens in real life. Okay, so let's say that you will buy a car, or for instance, let's just make this example, this problem example. So Engineer Salvador bought a car, which is paid for 5 years. 5 years to pay this one. Okay, that's 5 years to pay. There you go. 5 years to pay, and he is paying 15,000 per month. Okay, of course, we have an interest of 7% compounded monthly. Now, in real life, this happens, right? You are going to buy a car, and it's either 5 years to pay, 4 years to pay, 2 years to pay, whatever. So what I'm saying is, annuity is also called in layman's term in real life is installment. It is also known as installment, to put it simply. Now, the most common method of compounding in real life is, of course, monthly. Okay, so if the car is 5 years to pay, therefore you are paying for the whole 5 years every month. Right? So from the word itself, we are looking for accumulated amount. Therefore, from the word accumulated, we all know that we are looking for the future worth or the future month. Okay, so let's go to the problem. Let's put the events first. Given, so we have what, the 15,000. Okay, so 15,000, you are paying 50,000 per month. So you have a multiple payment for the whole 5 years. Okay, so that will be your annuity. Okay, so annuity, that is 15,000. What else? We have 7%, 7% interest compounded monthly, from the word compounded. Therefore, this 7% must be J, or the nominal rate of interest. So this is 7%. You must put this 0.07 as a decimal form. Compounded monthly. Therefore, your method of compounding must be equal to 12, and years, or your Y must be 5 years. So that's all. Okay. So we are required now to find the future from the word accumulated, the future amount. Okay, so let's go to the solution. Okay, so having the solution, we can just, this is just direct substitution. We have f again times a times 1 plus j over n is 2 yn positive will go into the future, so minus 1 all over j over. Okay, so inputting the values we'll have here, your A will be 15,000, 15,000 times 1 plus your J is 0.07 all over monthly. So N must be 12 and your YN must be Y is equal to 5 years and N times 12 minus 1. And then J again is 0.07 all over 12. Okay, putting that in our calculator, we have that's 1,000 times 1 plus 0.7. That's raised to times 12 times 5. It's also 60 minus 1. Okay, so that is 107. Okay, no, that's not 107. That is 1 million. So your future value now will be equal to 1,073,038,950.524. That means if you will pay 15,000 for the whole 5 years with an interest rate of 7% and compounded monthly, this will be the total payment you make for all those 5 years. So that means that after 5 years, this is the whole payment that you made. Okay. So with that, let's go to our next problem. Okay, going to our next problem, we have Engineer Gorospe bought a set of computers. If she is to pay 20,000 semi-annually with an interest rate of 9% compounded semi-annually for 5 years, how much is the total amount today? So from the word, oops, this one, from the word today, that means we are looking for our, we are required to find present word, right? So present word. So let's put the givens first. The given, we have 20,000. So you're paying 20,000 every semi-annual, for 5 years. So that will be your A, and then 20,000. And so what else? We have 9% compounded semi-annual. So from the word compounded, this must be your J. Oh, 9%, so this must be in decimal form. And then compounded semi-annually. So if you say semi-annually, you are paying 2 times a year. And your Y will be, of course, we are required now to find total amount today, so that's P or the present word. Okay, so you can have the solution. So we will use the P or the other formula. So we have A times 1 minus, again we're going left or we're going to the past, so it must be negative 1 plus J over N. Don't forget the negative 1 J over. There we go. Okay, so let's substitute all the values. We'll have here A will be, that is 20,000, times 1 minus 1 plus j, j 0.09 all over n, where n is raised to negative 5 years times semi-annual all over 0.09. So you will input that in your calculator. I already did that earlier in advance. So you'll have 158. The answer will be 158,254.363. Okay. So this will be your answer. So all of the payments that are made for 5 years, if you will reflect all of that today, the answer will be 158,255.363. With that, let's go to our next problem. Okay, so going for our last problem, I think so. So we have engineer Chu will buy a house with a price of 5 million if paid cash. So if he wants it fully paid in 10 years with an interest of 10% compounded weekly, how much must he pay every week? So now engineer Chu will buy a house with a price of 5 million if paid in cash. Right? If you will pay in cash, that means you will pay today. If ever you want to pay in cash, you will pay today, right? Not after 10 years, not after 5 years or whatsoever. So that 5 million must be your present worth. And he wants it fully paid in 10 years. The interest now will be 10% compounded weekly. So the question is, how much must he pay every week? So we are asked to find how much engineer Chu will pay every week. Therefore, we are looking for the amount paid or um, the annuity itself. Okay? So let's put all the details first again. We have 5 million. So that will be your present worth. Um, let's say 5 million. And then we have fully paid in 10 years. So we have y equal to 10 years. And then interest rate from the word itself again. Because of the word compounded, therefore your 10% must be your nominal rate of interest. So this must be 0.1. 0.1. And then compounded weekly, your n must be equal to 2. So now we are required to find the annual. Then, so going for the solution, we can just use the formula for the present word. So we have again P is equal to A times 1 minus 1 plus J over N raised to negative Yn. So all you have to do is just substitute all the values here, and then we can now find the value of A. So we have P, which is 5 million. Let's just put it 5 M. I hope that is okay. And A times 1, 1 minus 1 plus your J is 0.1, right? 0.10 all over 52. Don't forget the negative, okay? So negative, it must be negative. Y is 10 years times 52 over J is 2.10 all over. So you can now solve for the value of A. So using algebraically, I already solved it in advance. Your value of annuity now, that's 15219. 15219.82. Okay. So this will be your final answer. That means for the whole 10 years, right, Engineer Chu will pay 15,290.8246 every week. Right? Every week. If the interest or the compounded interest is 10%. So that's what it. So yes, I think this is all for this video, and I really hope I was able to help you during especially these online classes. So if you have any questions or any questions for this video, just leave a comment down below. And of course, everyone, thank you all for watching, and don't forget to subscribe and hit that bell notification icon so you will be notified as soon as I upload it. So again, I hope you are all safe in your houses, and thank you. And I'll see you on the next one. Bye bye.